Sustainability science, ideas and practice. Hum jumbo. It is a great honor for me to give this keynote address at the Institute of Resource Assessment celebration of the 50th anniversary of the University of Dar es Salaam. And it is with regret that I am speaking to you electronically, as this mzee has some difficulty in making very long travel trips. But I've had the pleasure of meeting your new Honorary Professor of Environment and Climate Change, Pius Yanda, in South Africa, when we both worked on the 4th International Assessment of Climate Change. I arrived in Dar 6 years after the founding of the university, partly at the initiative of Professor Berry, who gave the earlier keynote today. I served as the initial director for 2 years of the Bureau of Resource Assessment and Land Use Planning, BROLLIP, the forerunner of the IRA, followed by a stay as an honorary research professor studying drought adaptation in Tanzania and locally in the Usambara Mountains. And to remember this year's, my wife suggested that I bring along my 40-year-old university tie. Our 3 years in Tanzania were to change our lives. My wife, Eleanor, began her career in childcare. My children in their Tanzanian schools had unique experiences and friendships. My eldest daughter graduated from the Jangwani School for Girls. The direction of my research changed to encompass both environment and development, a path that would lead me to sustainability science, the topic of my talk this afternoon. Sustainability science. The ideas of sustainability science are at least 2 centuries old, and the practice is but a decade old. Today, I want to begin with Humboldt and the unity of nature and go on to discuss just what is sustainability science. Then I will describe 3 major tasks of sustainability science: to do fundamental research on use-directed problems, to nurture the next generations of sustainability scientists, and to move knowledge into action. And I'll illustrate each of these with some recent initiatives. Ideas of sustainability science. I have selected some of the major ideas that contributed to the development of sustainability science from a much larger set, beginning with Alexander von Humboldt's epic journey in South America, and followed by the publication of the Cosmos. And this was followed by George Perkins Marsh identifying the impacts of people on nature, and Vladimir Vernadsky integrating the biosphere and human cognition. The Bariloche Argentinian group created its own world systems model as a Latin American answer to the book called Limits to Growth. The International Union for the Conservation of Nature brought together environment and development, and that led to the World Commission on Environment and Development. And then more recently, the Earth System Community sought a science for sustainability, and all these ideas accumulated in the U.S. National Academy of Sciences report, Our Common Journey, and its specific call for sustainability science. Alexander von Humboldt's dream. Let me elaborate on the first of these ideas, beginning with Humboldt's dream. Humboldt, a German geographer, 29 years old, sets out his dream in 1799 in a letter to friends as he awaits his sailing from Spain to Venezuela and the beginning of his 5-year exploration of the Orinoco River and the Andes Mountains. He describes his dream as follows. In a few hours, we sail around Cape Finisterre. I shall collect plants and fossils and make astronomical observations. But that's not the main purpose of my expedition. I shall try to find out how the forces of nature interact upon one another and how the geographic environment influences plant and animal life. In other words, I must find out about the unity of nature. He would pursue the dream until the final posthumous publication of Volume 5 of his great work, The Cosmos, in 1862. But his dream was not to be shared widely, for by then the Academy had discovered another more powerful approach to understanding nature, but not to understanding its unity. To pursue this new approach of reductionism, scientific specialization increased, academic disciplines were born, and graduate degrees were invented. Sustainable development, good politics, little science. Sustainable development emerged in the early 80s from scientific perspectives on the interdependence of society and environment, led by the International Union for the Conservation of Nature. It gained considerable political attention through the publication by the Brundtland-led World Commission on Environment and Development report, Our Common Future, and the subsequent United Nations Conference on Environment and Development held in Rio de Janeiro in 1992. There were no scientists on the World Commission and little science present in Rio. 10 years later, at the Johannesburg World Summit, there was some scientific presence, in part because work on sustainability science had begun. The National Academy of Science Board on Sustainable Development. The most recent of the emergent ideas of sustainability science was the work of the U.S. National Academy of Sciences Board on Sustainable Development, begun in 1995. I served as vice chair of the board, and along with Bill Clark of Harvard University, we began a 5-year effort to reconnect science and technology to sustainable development. We sought to make the concept of sustainable development manageable and measurable for scientists by focusing on a minimal sustainability transition over 2 relatively foreseeable generations. To do so, we envisioned a world population in 50 years of around 9 billion. To decide what constituted a sustainability transition, we chose 3 normative goals that had emerged at the top of priority-setting negotiations of international conferences and world summits. Meeting the human needs of the 9 billion people while preserving the life support systems of the planet and reducing hunger and poverty. To do so, we argued for acting on what we already know and creating a sustainability science for what we needed to know. Freiburg Workshop on Sustainability Science. We finished our report in 1999 and presented it along with other national efforts to a meeting of the World Academies of Sciences, which embraced the notion of a sustainability science. But we also realized there was much to learn on how to do it. So with the assistance from Sweden, we convened a small international workshop in Freiburg to identify the core questions and methodologies of sustainability science, and this was followed by a series of regional meetings in Africa, Asia, Latin America, and North America. profound differences in problems and perspectives. Our discussions at Freiburg and in the subsequent regional meetings revealed profound differences in problems and perspectives between scientists based in developed countries, focusing primarily on global issues, and those in developing countries, focusing primarily on local issues, and separated by a variety of economic, digital, and capacity divides. Scientists in the North worried about the effects of affluence and consumption, climate changes and its causes, and undertook theory-driven research. Scientists in the South worried about the effects of poverty and underconsumption, the impacts of climate change, and undertook action-driven research. Scientists in the North took for granted broadband internet access and many sources of funding. Scientists in the South tried to cope with interrupted electricity, with multiple jobs needed for their sustenance, and few sources of funding. But there was also broad agreement that sustainability science should be essentially integrative and bridging. Science and technology for sustainability should be essentially integrative, working to integrate the natural, social, and engineering sciences to bridge the communities engaged in promoting environmental conservation, human health, and economic development across the multiple sectors of human activity and relevant geographic and temporal scales, and bringing together the worlds of knowledge and action. Also, sustainability science is regional and place-based. Our discussions also revealed agreement that much of science and technology for sustainability will need to be regional and place-based, focused at these intermediate scales where multiple stresses threaten or degrade human environment systems. In a sense, sustainable development differs in every place. As human needs vary, life support systems differ, and hunger and poverty is smaller or larger. For sustainability science, it is at these scales that the complexity of human environmental systems is more readily comprehensible. Local and regional integration is possible. It is where innovation and sustainability solutions take place and where significant transitions towards sustainability have already begun. But sustainability science is simultaneously fundamental and applied. But our global conversations concluded that science and technology for sustainability will need to be simultaneously fundamental and applied, addressing cutting-edge questions regarding the interactive nature-society system and its evolving dynamics, even while recognizing the concurrent need to address sustainability concerns in a problem-solving mode, applying what we already know in science-based action programs. The quadrant model of scientific research is instructive, with its 2x2 view of research contrasting the quest for fundamental understanding on one axis with the quest for utility or usefulness. Thus, there is the Niels Bohr quadrant, high in fundamental understanding and little utility, and that of Thomas Edison in the pure applied quadrant, high in utility and little fundamental understanding. In contrast, the sustainability science quadrant of use-inspired fundamental research is exemplified by the discoveries of Louis Pasteur. Sustainability science is, in my view, that of the proceedings of the National Academy of Sciences definition. Quote, an emerging field of research dealing with the interactions between natural and social systems and with how these interactions affect the challenge of sustainability, meeting the needs of present and future generations while substantially reducing poverty and conserving the planet's life support systems, unquote. Major tasks of sustainability science. I see three major tasks for sustainability science. The first is to fulfill the Pasteur quadrant and do fundamental research on use-directed problems. Important as well for a science that sees itself active over the generations is to nurture the next generations of sustainability scientists. And as our new knowledge accumulates, we need to move it into action. For each of these, I would like to illustrate the task with three examples. Fundamental research on use-inspired problems. Now to the first of the tasks and three recent examples. Major questions, new sources of publication, and recent research results. Sustainability science questions and themes. There have been two major attempts to put together core questions for sustainability science. The first was the Freiburg Workshop of 2000, where 7 core questions were identified and reviewed by the regional meetings in Africa, Asia, Latin America, and North America. Last year, at the initiative of the U.S. National Science Foundation, a useful conference on Towards a Science of Sustainability was convened. There were twice as many conferees as in the original workshop, but unfortunately, unlike the first workshop, most were from the United States. The conference identified 6 sets of major thematic research. If you combine these core questions and thematic research, there are 7 major questions for research. 1, what shapes the long-term trends and transitions that provide the major directions for this century? 2, what determines the adaptability, vulnerability, resilience of human environment systems? 3, how can theory and models be formulated that better account for the variation in human-environment interactions? 4, what are the principal trade-offs between human well-being and the natural environment? 5, can scientifically meaningful limits be defined that would provide effective warning for human environment systems? 6, how can society most effectively guide or manage human environment systems towards a sustainability transition? 7, how can the sustainability of alternative pathways of environment and development be evaluated? Publications, many new sources. The growing sets of sustainability science research results have many new sources of publication, including traditional journals such as Global Environmental Change or the Proceedings of the National Academy of Sciences, new journals such as Sustainability Science or the new Brazilian multilingual journal Sustainability and Debate, internet journals such as Ecology and Society, review volumes such as the Annual Review of Environment and Resources, and more popularly written pieces as an Environment magazine. To share your experience here in Tanzania, it is worth the additional effort to publish in the many new publications. Research results. Many of the research results for fundamental use-inspired science appear in the PNAS, the Proceedings of the National Academy of Sciences, and in its newly established Sustainability Science section. Since 2003, there have been 232 articles, many of them in special features, that characterize the range of current sustainability science research. These include features on poverty, on health, governance, food security, climate change, and land use change. Sustainability science research needs. Let me conclude these examples of fundamental use-inspired research with a bit of a critique, singling out 4 emphases still evident in current efforts. There is a clear emphasis in sustainability science towards environmental science, the varied fields of development sciences that include health and human development, economic and social development, governance, and the multitude of technologies that make development possible are still underrepresented. Despite the encouragement of sustainability science on regional and place-based studies, many studies seem to address global or continental scale. Finally, and perhaps most important, we need to overcome our normal penchant to do research rather than solve problems and create solutions, and to acknowledge how much we already know about the crucial needs of a sustainability transition. Now turn to the second task, nurturing the next generations. Sustainable development is a long-term effort. Thus, the best sustainability scientists may not have been born yet. So let us turn to the second of our tasks, that of nurturing the next generation of sustainability scientists. Here are 3 examples. The full range of educational opportunity that Arizona State University in the United States offers. The just completed readings in sustainability science and the distributed graduate seminar in sustainability science that was held last year. The ASU School of Sustainability. Since 2002, President Michael Crow has been refiguring Arizona State University into a new type of American university, featuring, among many things, an emphasis on sustainability. There is a sustainability effort throughout its various schools, with the intent of sustainability ideas being introduced eventually to all of its 74,000 students. But there is also a specific school of sustainability, which had, as of last September, 581 undergraduates and 84 graduate students, 58 of whom are PhD candidates. Tanzanian students seeking graduate study abroad might consider that program as an option. Readings in sustainability, science, and technology. As educational opportunities continue to increase in sustainability science, there is need for new sets of educational materials. A major effort over 4 years are the readings in sustainability, science, and technology. For teachers of advanced undergraduate students and beginning graduate students, it suggests a 3-part architecture for sustainability science. The first, focusing on sustainable development, its history, the dual needs for promoting human well-being and protecting the life support systems of the planet, and how these come together in human-environment interactions. The second part addresses the approaches, methods, models, used in sustainability science. And the last part describes examples of knowledge that should be moved into action and features for each need a local and global example. In all, there are some 93 readings to choose from, as well as a mini text of 60 pages that can be used as a primer. And as an electronic reader, it can be frequently updated with the help of colleagues around the world. Sustainability Science Distributed Graduate Seminar. Last year, the first internet-based distributed graduate seminar in sustainability science brought together 120 students from Arizona State, Cornell, Florida International, Harvard, Minnesota, the National University of Mexico, and Princeton. Each week, one of the participating universities offered speakers, facilitators, and most important, their students, who took the lead in commenting and posing questions. Draft chapters from another new educational source, Sustainability Science and Introduction, were used as textual material supported by the reader. These materials can still be downloaded from their website. Now to the third task, moving knowledge into action. Now for what may be the most challenging task of sustainability science, moving knowledge into action. I will begin with tracking the global and local agendas of action and report on major initiatives that act on what we already know how to do, and conclude with a suggestion. Knowledge into action agendas. Dr. Brundtland and the World Commission on Environment and Development identified 6 challenges for sustainable development: population and human resources, food security, species and ecosystems, energy, industry, and urban. The National Academy of Science Board grouped 2 together and reduced these to 5. The Secretary General of the UN, Kofi Annan, added water and health to 4 of these as an achievable agenda of the 2002 Johannesburg Conference. My own reader keeps all of these, but expands the agenda to specifically include 3 cross-cutting grand challenges of sustainable development: poverty, climate change, and peace and security. Seeking solutions, local and global, to improve health. The reader describes examples of knowledge that should be moved into action, and features for each need a local and global example. For the local health example, it includes a paper from the Tanzania Journal of Health Research that describes a recent effort in Tanzania to bring together usually separate community-directed health interventions against malaria, onchocerciasis, tuberculosis, and vitamin A deficiencies. For the global example, it uses the global measures advocated by the Gates Foundation. Acting on what we already know. We have had a consistent agenda of sustainability challenges and problems for 2 decades. Thus, sustainability science does not start from a blank slate. Indeed, we already know ways of moving to a sustainability transition over the next 2 generations. For example, we know how to reduce the expected 9 billion population by as much as 10%, by increasing current trends in fertility reduction that meet unmet contraceptive needs, educate women, and delay marriage. Africa can produce much more food just by increasing its use of fertilizer. We can double the rate of improvement in reducing energy by using technology and behaviors that are already available. Rapidly growing cities of developing countries can be made to work efficiently, provide housing and employment, and become increasingly green. And we have learned much in how to restore degraded ecosystems. Acting on what we need to know, a sustainability solutions initiative. But here in Tanzania, in particular sectors, regions, and places, there is much we need to know. So let me suggest creating a sustainability solutions initiative to seek solutions to local and regional problems. What makes the Sustainability Solutions Initiative different from academic research? The problems are jointly identified by scientists, practitioners, and potential users of the solutions. Success is seen as solving problems and implementing solutions, not just seeking new knowledge. To create a portfolio of problem-solving projects, you might use Kofi Annan's sectors of WEHAB: water, energy, health, agriculture, biodiversity, and add to these the urban sustainability problems of your rapidly growing cities. Affecting all these sectors is climate change, and your new Climate Change Research and Education Center can be a lead component in your Sustainability Solutions Initiative. Alexis V. Humble's dream. Now, having nurtured the next generation, and perhaps the one after it, let us return to their unity of nature and their dreams. I have named my future sustainability scientist Alexis V. Humble, and this is her dream. She texted it to a friend. In a few hours, we launched from the African spaceport the first of the next generation of sustainable Earth-observing satellites. We shall collect full-spectrum data on populations of people, plants, and places, the atmosphere and oceans, the movements of energy, materials, and information, of warfare and welfare, and of environment and development. But that's not the main purpose of our science. We shall try to find out how the forces of nature and society interact upon one another, and how the geographic environment and the complex system of life can sustain itself. In other words, we must find out about the unity of nature, a nature that includes we humans. Finally, across the miles, thank you for your attention and patience.